Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about death of Hyperloop. So let's dive right into it. Now you have to understand the idea. What's the idea? The core idea behind it is basically vac train that was invented by Robert Goddard. I have no idea how the heck people did not relate that like this guy is flat out copy pasting in the idea, but somehow Elon Musk successfully managed to convince the world the idea is his, and he called it, rebranded it basically Hyperloop, and he called it fifth mode of transport. And he's gonna make a white paper. Now at that point in time, basically around 10 years ago, around 2012, the idea was that he was busy with SpaceX and Tesla, and he was like, I'm too busy for it, so I'm gonna like open source it. Like, how the heck you can open source something that is not yours? But again, Elon Musk. So this was the idea behind it. Now be very mindful, this gentleman is very qualified, very successful individual, and there have been many attempts, prototypes, large scale tests, and with real human testing done with wax train. All of them have failed, and there is a reason behind it. So let's dive right into it. Now be very mindful, if Elon Musk was removed from this puppy, flat out it will not work. Flat out, like the idea of Hyperloop would have died before it even got off the ground. So this is one thing you must understand. Every system level engineer was like, just face palming. It's like, what the hell? Now you have to be very mindful. There are engineers who are very fine-tuned with one topic, like let's say electrical engineer. You're like, dude, give me the electricals of that system. They're like, I got you, fam. It's like he does not care whether it's like whether you're putting electricals on a car, electric car, or a metro or Hyperloop. It does not care. It's like I am a guy who knows one thing and I'm very good at it, specialist, so to say. However, because of that reality that some people are very specialized and very good at one task, there are different kind of system level engineers who are like, I'm going to design the bridge, but then there will be different engineers like, I'm going to design the bolts that are used. I'm going to figure out the alloys that are used. You get that? Like there are cascade level of engineers here. So every system level, basically people who have trained in looking at the bigger picture, be very mindful of that. Looking at the bigger picture, they're like, no, just no, because be mindful, engineers are responsible for the budgeting. So flat out engineers went no. And if Elon Musk did not have that cult kind of personality, flat out it would have died exactly like how it died in past 100 years. So be very mindful. If you want to look up vac train, people have physically made it. It's not some sketch, some rough diagram. No, people have made it, and it's like it failed. That's why we have never tried to resurrect this puppy for 100 years. So that's why you have to understand this. And many times, even people I respect, like Elon Musk, I'm saying basically, Linus Tech Tips of LTT fame, and he was talking about like, the people working there, like, basically they don't know science. Here's the deal. Many times people do not work as a grander picture. They just work because that's their job. Like, you pay me the money, I do the work that you ask me to. I don't care where you're gonna employ this work. Like, for example, let's say a system engineer who's like, he's optimized in making your cooling system for vacuum system, meaning it's up to you. You want to use that vacuum system for vacuum of outer space, vacuum of some test chamber, vacuum of Hyperloop, does not care. It's like, dude, you pay me, I do the work. How do you use the work? That's up to you. So many people just like, educated, qualified people are working on this, so that means it's correct. No, that's not how it works. Simply because many people are just there to do their job. Like, you pay, like you tell them, like, let's say even that engineer who's like actually working here is like, dude, this is stupid. It's like, then why the heck you are working there? I'm getting paid. It's like, if you're getting paid to do something, you do that thing. That's the whole point of a job. So this is one thing. And another aspect is many universities are pouring their money into this. Now you have to understand this. University costs are kind of stupid at this point in time. So a lot of people are just like, what, I would love to go there, but like, I really don't want to sell my kidneys. So they're like, the enrollment is not going as high as people want it. So popularity in sort of that sort of context is really important. Meaning, if let's say University of MIT, some universities from Japan, some from India, so these sort of universities, they successfully competed in this puppy and they got some recognition that will directly translate into getting more enrollment, which is a really good thing from university. That's good enough. That's directly marketing. So popularity is good enough driver where they're like, dude, I don't care whether this works or not. Does it get us the good press? Does it get us the recognition on the international stage? Does it get a more enrollment? They will do it. They will like, shut up and take my money for this. So that's the reality behind it. That's why like many times people, if give you that example where it's like, the educated person is working on that, look at that motive, look at the motive, why that person is working. Is he getting paid to do that? Of course he will do that. He would not care. It's like, that's how scammers like, there are many scammers who use CGI. I used to be CGI game artist. Now would I work for a scammer? Of course. It's like, dude, you pay me, I do the work, you do whatever you want to do with it. You go to any freelancing site, that's how it works. It's like, you pay me, I do the work, I'm done. What you do with that work, that's up to you. I have to sign a freaking giant 18 paper NDA for that. It's like, I don't care what you do with this. So be very mindful. That's how people are like, sliding through it, because again, specialists will not understand this. Specialists will like, sounds good, but system level engineers will be like, dude, this will not work. The cost will simply not work. Basically, engineers face. Now, what are the problems? Exactly, let's break it down. Now, be very mindful. This is my third video on this topic, and I have already covered year after year degradation of Hyperloop, but I will not repeat that. So I will give you a simplified explanation. There are only 3 layers in reality. Layer number 1, physics. Is this system breaking any known laws of physics? No. That means it's not like EM driver. It's like, dude, fundamentally this should not work. So it works. Awesome, that's good. That's like layer 1. If anything breaks that, like a quantum battery and like, Hululu batteries, yeah, that won't work. So does it work within the known laws of physics? Awesome. Then you have second level. What about the engineering problems? Again, you are wanting to do some things. Can you solve it? For example, you make a tube. Awesome. You vacuumified it. Here's the atmosphere will crush it. Okay, how do you solve it? There are 2 ways of solving it. You can make the wall thicker, or you can have supporting ridges that will give the strength. That's how we make basically hull for the submarines. Okay, that's awesome. Again, there are problems, you can solve it. Now, are the problems that are present in Hyperloop, are they solvable? Physics wise, yes. Engineering wise, yes. Now here's the deal. There's the granddaddy layer. You have physics layer, child's play. You have engineering layer, a bit more complex. Then you have granddaddy layer, which kills 100% of the project, almost 100%. Cost. Can you solve all the problem related to Hyperloop? Absolutely. Solving all the issue will make the cost lol, meaning you will not even ask how much it's gonna cost. You'll be like, cost? Yes. That's how stupid it will go, and that's the end game. Think of it this way. We used to have supersonic passenger jet. Like, used to have. Let that sink in. We barely travel at like around 600 to 800 kilometers per hour, and we used to, as in our past, as in 1990s and like early 2000s, we had the ability to travel at Mach 2. We used to have this. What happened? Like, engineering was physics allowed it, that's why it happened. Engineering allowed, we physically made the plane, and what happened after that? Why did it was grounded and like never revived again? Cost. Fuel price went YOLO. So reality is, that's the 3 layer. Almost anything can be done in physics, anything can be done in engineering, in small scale, in lab testing. All those things can be done easy, but the final nail in the coffin is always cost. Does it work within the known budget? Yes, awesome. No, go away. Like, why the heck USA stopped going to the moon? It was costing 4.5% of national basically budget to do that. NASA does not have that kind of budget anymore. That was Cold War spike budget. After that, what's the current budget? 0.45%, like under 1%. So you get that point. Cost matters more than anything else. Can you make laws of physics? Of course, that's the granddaddy layer in terms of like, can you do it? Should you do it? Should you invest in it? That's the first layer. Second layer, engineering. Third, the final that actually makes sure that something becomes truth, reality, common thing, that's cost. Always the cost. Now, common people do not have the context of like how expensive railway is. Normal railway, I'm talking like Indian railway, like it's a huge network. Idiotically huge network. To give you a context what kind of huge numbers we are talking about, amount of people that are in Indian railway on wheels moving at any given moment in time, it's equivalent to the population of Australia. Imagine whole Australia moving on trains. India. So that's the scale of this puppy. Now this puppy is expensive. I'm talking normal train, not basically normal train that's not crossing 200 kmph. Now you have to buy the land, which is expensive. Even if you remove the land, because you have to buy that for whatever you are building, you have to buy land. Okay, let's remove that. Let's put that as a fixed variable. You still have to, stabilize that slope. If it's a gradient, you have to make the gradient. You have to stabilize the founder. You have to stabilize the soil. Everything. Like, you have to make it strong enough where it can handle multi-ton object going on top of that. Then you have to have ballast. Then you have to have slippers. Then you have to have rails. Then you have to align them, balance them. All of them are very labor intensive. Even with automated machines, those machines are not cheap. So fundamentally, per kilometer wise, like let's say you have a project of 100 kilometer, or you want a project that is open-ended, meaning you will lay down one line here, then as demands grow, you will add another line. That's how Indian Railway grows. You want to know what we call kilometer, basically cost per kilometer. So normal railway, just for number 6, assume 10. let's say it cost $10 million. Now what about high speed railway? Now this will be going around 200. That's too much. Generally they are below 200, and high speed is above 300. So this puppy will cost around 10 times more than this, and I'm being very generous. Generally it's even more than that, but 10, then that's a bare minimum. Now what about going from high speed to maglev, magnetic levitation systems? Now they do work. They have been in services for last 50 years, and they have been like, oh, that's the first mark of a sci-fi, like they're always maglevs. Like, everybody is no longer is using wheels. Now reality of this puppy is this is like almost 10 times more again. So this will start, let's say, $10 million per kilometer, $100 million per kilometer, 1,000. So that's why, like, these things are stupendously expensive. And now imagine this, like A, B, C. Now you want to do this maglev system inside a vacuum tube. Just the raw steel cost will bankrupt you. Just the amount of steel you have to make in order to make a tube that can withstand vacuum and withstand thermal stresses of being outside, and not to mention, because it does not have air inside, the thermal stress would be much more brutal, because again, it does not have anything that is convecting heat away, and inside of it's like there is something that is moving. So, and not to mention the pylons, and because of the speed, it has to be a straight line. It has to be in very little curves. Everything has to be gentle. So land acquisition cost will go ludicrously up. So all those things combined, the cost per kilometer would be in stupid territory. To give you a context of that, Japanese people generally do not like the idea of, like, they like the Shinkansen, but be mindful, Shinkansen is like a luxury in Japan. Not everybody can afford it. It's like expensive. It's like middle class people or above can only afford that. That's expensive. And this puppy it's a lot expensive. Even Japanese government is like, should we really do this? Because that's how it was sold to them. Like, we are developing this technology and we are sell it to other people. And people who know the reality, economics is like, dude, who will buy something as hyper expensive as this? No, like China is doing that. But here's the deal. If you pay attention to China's hyper speed rail network, you will notice most of them are Shinkansen. Only few links as a national prestige project is made into this. Other than that, there is no single reason to do this. Yes, it's a double fast, but it's not worth it. Like, flat out, the track cost alone will bankrupt you. So fundamentally, would you have 10 kilometer of this or 100 kilometer of this? Every scenario, 100 kilometer of this will be far more cheaper, easier maintainable. Everything would be awesome about this. This is not. So that's the problem behind it. Cost per kilometer, flat out. Flat out is like, yeah, we cannot do that. Elon Musk was saying, like, this will be cheaper. Again, he's not a system level integrator. It's like the moment a system level integrator looked at that statement, it's like, dude, you lost some screws. Lot of screws. Now, what about the danger? Because recently this sort of talk started to happen because some big news happened, which I will talk in the last slide. This word will come up. It's dangerous. Now, reality is, it's one of the worst option, and it's one of those things that sometimes rich people kind of leave the nitty-gritties too much. And you will see that with Richard Branson, again, indirectly connected to the story, when he was making Virgin Galactic. And I'm old enough, he was first announced that it will be safer than plane. Yes, really, accident did happen. Loss of life did happen on the system. How the heck something that is safer than plane had, loss of life before it even went to space? It happens. Any undeveloped system is untested. Untested things cannot be qualified as safe. Fundamentally, like, have you flied it 100 of times? No. Then how the heck you know it's safe or not? Because think of it this way, like space shuttle. If you're like, a space shuttle would be classified as safe if you only fly it 10 times. You're like, dude, space shuttle safe, awesome, 100%. No, it's not. Because at 21st mission, boom, happened. And again, you have to do it hundreds of 50 times, then you find it blows up 2 times. Then you're like, dude, that's too high of a failure rate. That's unacceptable at that point. So that's why you have to do numbers in order to justify whether it's safe or not. You cannot say safe or unsafe before it is even built. So what are the risks involved? Let's say from a physical point of view, what are the risks? Fire, it's brutally risky in this environment, simply because fire in enclosed spaces like submarines, it's brutal. Fire inside tunnels, they are extremely brutal, meaning even normal petrol fire, diesel fire can literally cause melting of the metal, because heat will have no place to go. As long as oxygen is feeding here, good luck. Like, people, that's the worst nightmare. Like, if you ever seen any footage, news footage of tunnel fire, it's horrifying. It's like, it literally looks like hell, because it is hell at that point in time. However, now take this puppy, worst case scenario, amplify it. Why? Because again, heat flux travels. Heat flux does not like to stay in one place, but it has to have something in order to travel. For example, in case of a pod, let's say pod is moving, it's surrounded by what? It's surrounded by vacuum, or almost low atmosphere, where it's like, yeah, it does not have enough molecules to conduct heat away efficiently, meaning it's gonna be cooked from inside. Now, like, what's there to burn? Well, let's say it has batteries. Batteries can burn even in a vacuum, so it can dump heat without any issue. And inside the pod, you have oxygen, meaning other things can catch on fire. So let's say mobile phone battery going boom, Yeah, it could start a fire, small fire, but here's the, because there is no place for heat to escape, because you have surrounded it with one of the world's best insulator, it's gonna be brutal. Meaning small fire, meaning let's say even 1 liter propellant fire, like petrol or diesel, would be brutal. Like people have scenarios where they have survived train fires, they have survived aircraft fire. They will not survive a vacuum, surrounded by vacuum fire. They will be cooked instantaneously. Heat stroke would be brutal. So that's bad. Then we have depressurization. Now depressurization is a thing that people have experienced, like aircrafts. Now in aircraft you have oxygen mask. Now you have to understand this. It only goes to, like, let's say 50% of the atmosphere. Meaning if sea level is 1, you're only going 1/2. However, every pilot has been trained properly into one statement. Meaning if you have emergency depressurization, you drop this puppy down and you drop it fast. You do not think about anything else. That's all you do. You call mayday, mayday, you drop this puppy and you drop it to 10,000 feet. Now, why? Because at that point you can breathe. A normal human can easily breathe. So this mask becomes redundant at that point. Basically, these masks are there just for that dropping down period and just to, like, ease your shock and all that. And not to mention, way too many people do not know how to put it. They put it like here, your nose is exposed. So you get that point. Like, this is safe, this is doable, because plane has 3 axes of freedom. What the hell you gonna do inside a tube that's traveling at very high speed and some leak happens? Because again, it's a thing made by human. It could have human flaws, it could have design flaws. Things happen, like, it's human. We make things, it breaks things. So sometimes something bad happen. What then? You are surrounded by vacuum, you can't open the door, you can't drop anything, you're gonna suffocate. Now here's the deal. What if you have the same oxygen mask? It will not work, simply because you are surrounded by vacuum, not surrounded by, like, low pressure. You are surrounded by vacuum, meaning your muscles will swell up. You will have basically dissolved gases in your body trying to rush out. It's gonna be very brutal. And, like, you can only survive, like, for a few seconds. Like, compared to a normal plane, even in high altitude, even without the mask, you have few minutes, like 1 or 2 minutes can be there. But in case of a vacuum surrounding, good luck. So that's the whole point. It will make depressurization in aircraft look like, who cares? And this will be the only method of transportation where, while it's on the surface, it has 100% fatality, meaning any accident, even minor or small, will translate to instantaneous death. Because while plane do crash, it is a thing, people have started to survive on this. It has happened. And again, planes are the worst case scenario, because generally their grand total number is safe, meaning 100,000 planes took off, almost 99.999% landed successfully. That's awesome. But here's the one that does crash, does have a tendency to, like, go 100%. However, generally on land you do not have such issue. Even with high speed railway, whenever accidents happen, in case of Japan during earthquakes, or in case of Germany, some accidents has happened, people have survived. Like 500 people went in, again, loss of life happened, sometimes as high as 100 or 200. In this sort of scenario, it will be 100%. However, like, let's say 20 people in the pod, they did, because of the speed involved and because of the fact that you are limited. It's not a plane where it does have the luxury of 3-axis motion. It's just like locked inside a tube. Minor infraction equals done, 100% fatality. And the whole network is single point failure prone, meaning assume you have a, let's say, Mumbai to Pune link. That link is 500 kilometers. Let's just go with that. Anywhere fault in this 500 kilometer means you did. Anywhere. Now, railway is similar to that. Yes and no. Yes, if the bridge fails, it fails. But again, we have electrical systems that detect, continuity into railway tracks. If it detects something wrong, it will trigger a signal. And because of the slow speed, you have time to react. Other people can also react. And some scenarios, you may have security cameras, especially with high-speed railway network. They have people who are observing these sort of systems. Like, hey, everything looks good. If something is faulty, they trigger it. In case of this, good luck. So there are actual tangible dangers with this puppy which cannot be addressed. You cannot change some, because again, you have to remove vacuum to remove most of the problems, and you can't remove that. It will simply not work. So what's the reality behind this? Like, again, the hype, the pro people, the anti people, the con people, everything. What's the reality? Reality is Virgin Hyperloop did something, and that's why I'm making this video. They let go of half of their staff. Now that may not sound as such a big deal. It's yeah, letting go, but here's the deal. They also switched their company statement. Their company statement went from for freight and people through freight only. Now that's a very important thing. They are the only one who have physical, real world prototypes. Real world. I'm not talking some, like, CGI. I'm not talking some, like, we made vibranium. No. I'm talking real world where people have been put inside, and inside the chamber, like, again, speed was nowhere near how it's supposed to be because the tracks are too small. But okay, something assembling, like, what will be the final product. This is the only company that has full scale units. And After building this full-scale system, they have realized flat out this is gonna go bankrupt, flat out. And be mindful, it's very painful for me because they are the contractor for India, Mumbai Pune link, Mumbai, and that's why like you see this flag system. They literally got paid to do this. My government paid them money, hundreds of crore, lots of money basically. And here's the deal. This is one thing I want to ask you. Like, this is a company that physically built it. Like, they have actual real world experience, like what it takes, airlocks, all that jazz. What kind of freight can you think of in your mind that worth all this? Let that sink in, because like we people pay the most amount of money. That's why we travel by plane while freight travel by cargo ships. That's the reality. Like, cargo ships are not time sensitive, so you do not want to pay too much for that. You're like, take your time. Everything, even like a FedEx mail and all that, it's not very high priority. But think of it this way, person is very high priority. If you're not gonna do with people, how the heck you're gonna justify it? How the heck you're gonna justify that I'm gonna buy a huge chunks of land for hundreds of kilometers and I'm gonna build something on top of that? What equipment, what thing is worth it where you're like, I'm gonna build all this and people are gonna use my services? There's nothing. Flat. Even transporting gold is like, dude, armored carriers are cheap enough. We got this. Anyway, like, they used people, then why they are crashing it? That's the reality. Realization of safety factors is like, yeah, you can make it safe. The moment you add the kilometers to it, like 1 kilometer, you can make it safe. The moment you say, yeah, make it safe for 100 kilometers, yeah, no, that's not happening. Because the biggest issue would be this airlock. You have to have multiple airlocks. That's the only way you can have a system where one failure does not lead to cascade failure. But if you have airlocks, that means fundamentally they have to have a doors that opens and closes. That means the door itself becomes the issue. Because you are traveling such a high speed, if a door malfunctions, like let's say slams, it can guillotine directly the pod, or let's say it fails to open, done. So that creates an issue. That's why human safing it, good luck with that. Again, small patches can be human saved. That's why it was done. But long patches, long stretch, when you have 20 plus people using it hundreds of times a day, good luck with that. That's the reality behind. There is no freight that can actually give you the money value where this is justified. And you have to understand, every other company, there are around total 50 companies that are claiming this. All are fluff, meaning they build carbon composite, they call it vibranium. Yeah, no. And others are just CGI. And that's why, like, even my recent videos few months ago, I was talking about like fake projects. The first mark of fake projects, CGI. I used to be a video game artist, so I know how CGI looks. It's like, anytime you only see CGI, just let it go. Just don't even think about it. Just let it go. This was the reason everybody was like, see, they actually did it. It's not fake. I'm like, it's not gonna work. Not because physics or engineering is stopping it, because the economics will collapse it. Ta-da! That's why. Now, this marks the downfall of Hyperloop. Hyperloop virus has been spreading all around the world, hundreds and millions of dollars. In some scenario, grand total maybe $1 billion scam. This puppy has already consumed and burned for nothing to show for it. And is finally starting to die down. Finally, people are like, maybe this was a fake scam. And I expect next 5 years, meaning by 2025 or 2028, this would be finally sorted. People would have realized this was a vaporware. This was just to burn money, just for the lawler, just a vanity of one individual, and stupidity of goddamn nations caused this virus to get out of control. That's my expectation. I hope. So this was my presentation on death of a Hyperloop. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.